Hello dear students, all of you welcome to Vidyan classes. Today we will discuss some IIT JEE questions. First question, the range of the function for real x of y is equal to 1 divided by 2 minus sin 3x is dash. What is the range? The set of all images is called the range, or collection of y values for the given domain is called the range. Solution. For all x belongs to real set, x belongs to set of real numbers, sin 3x greater than equal to minus 1 less than equal to plus 1. For all values of x, sin 3x greater than equal to minus 1 less than equal to plus 1, which implies multiplying minus 1 everywhere. It gives 1 greater than equal to minus sin 3x greater than equal to minus 1. Adding 2 everywhere, it gives 2 plus 1 greater than equal to 2 minus sin 3x greater than equal to 2 minus 1, which implies 3 greater than equal to 2 minus sin 3x greater than equal to 1. Which implies 1 by 3 less than equal to 1 divided by 2 minus sin 3x less than equal to 1. Since xy greater than 0, x greater than y implies 1 by x less than 1 by y, or greater than or equal to x greater than equal to y, 1 by x less than or equal to 1 by y. 3 greater than equal to 2 minus sin 3x greater than equal to 1. On a reciprocal, it gives 1 by 3 less than or equal to 1 divided by 2 minus sin 3x less than equal to 1, which implies 1 by 3, this value is y less than equal to 1. So the range of the given function is the close bracket 1 by 3 and 1, which implies y belongs to close bracket 1 by 3, 1. So the correct option is A. That means y greater than equal to 1 by 3 less than equal to 1 is the range. That is range of y, range of the function is close bracket 1 by 3, 1. Y greater than equal to 1 less than y greater than equal to 1 by 3 less than equal to 1, or y belongs to close bracket 1 by 3, 1. That is range of the function is close bracket 1 by 3, 1. So the correct option is A. Clear? Note down. Question number 2. Let gx is equal to 1 plus x minus x bracket and fx is equal to minus 1 if x less than 0, 0 if x equal to 0, 1 if x greater than 0. Then for all x, f of gx is equal to dash. Solution. Set of x is equal to x minus x bracket. X minus x bracket represent the fractional part of x. Set of x represent the fractional part of x. It is a function which is equal to x minus x bracket, whose values greater than equal to 0, less than 1. Graph of x minus x bracket. It is the graph of x minus x bracket, whose maximum value is less than 1 and minimum value is 0. In this interval, it is 0, 0, 0, 1, 0, 2, 0, minus 1, 0 and minus 2, 0. When x lies between 0 to 1, that means x greater than equal to 0, less than 1, the value is, the maximum value is less than 1 and the minimum value is 0. X minus, the graph shows x minus x bracket greater than equal to 0, less than 1. For example, x equal to 0 implies x minus x bracket is equal to 0. X is equal to 0.1. X minus x bracket is equal to 0.1. X equal to 0.2. X minus x bracket is 0.2 dot dot. X is equal to 0.9 implies x minus x bracket is equal to 0.9. In this interval, when x greater than equal to 0, less than 1, the value of y less than 1, less than 1, it is open bracket. X greater than equal to, for all x belongs to R, x minus x bracket greater than equal to for all x belongs to R, set of real numbers. In this interval, the value lies between 0 and 1. x minus x bracket greater than equal to 0 less than equal to 1 for all x belongs to R, which implies x minus x bracket plus 1 greater than equal to 0 plus 1 less than equal to 1 plus 1. Adding 1 everywhere, 1 plus 0 less than equal to 1 plus x minus x bracket less than 1 plus 1. X minus x bracket plus 1 is equal to gx. Gx greater than equal to 1 less than 2, which implies gx is greater than 0. Gx is a positive quantity, is a positive number. Gx greater than 0. Since gx is greater than equal to 1 less than 2, we have to find out f of gx. Given fx is equal to 1 if x greater than 0. Given fx is equal to 1 if x greater than 0. Putting gx for x. Putting gx for x. The right hand side is a constant. F of gx is equal to 1. Since or as gx is dash, gx is greater than 0. Fx is equal to 1 if x greater than 0. Here gx is greater than 0, so f of gx is equal to 1 as gx greater than 0. Clear? Once again, I repeat, bracket of x which is equal to x minus x bracket represent the fractional part of x. That means x minus x bracket greater than equal to 0 less than 1. All numbers are fraction for every x belongs to R. X minus x bracket greater than equal to 0 less than equal to less than 1. For example, x equal to 0, x minus x bracket equal to 0, x is equal to 0.1, x minus x bracket is equal to 0.1, x equal to 2, x minus x bracket is equal to 0.2, x equal to 0.9, x minus x bracket is equal to 0.9, x is equal to 0.99, implies x minus x bracket is equal to 0.999. For all x belongs to R, x minus x bracket greater than equal to 0 less than 1. Adding 1 everywhere, 0 plus 1 less than equal to x minus x bracket plus 1 less than 1 plus 1. But this value, this is gx. Gx is 1 plus x minus x bracket. Gx greater than equal to 1 less than 2 implies gx greater than 0. Given fx is equal to 1 if x greater than 0. Fx equal to 1 if x greater than 0. Putting gx for x, f gx is equal to 1 since 1 is a constant. Fx is equal to 1, x is greater than 0. Fx is equal to 1 if x greater than 0. F of gx must be 1 as gx is greater than 0. Or putting gx for x, the left hand side is f of gx must be equal to 1 as gx is greater than 0. Given fx equal to 1 if x greater than 0. Clear? Clear? So the correct option is f of gx is B. That is 1. F of gx is 1. Clear? Next question. Question number 3. The domain of the function y is the function of x is given by the equation 2 to the x plus 2 to the y is equal to 2 is dash. Domain of the function, that means collection of x values. Two to the x plus 2 to the y is equal to 2. The equation is given by 2 to the x plus 2 to the y is equal to 2, which implies 2 to the y is equal to 2 minus 2 to the power x, which implies y is equal to log 2 minus 2 to the x with base 2. Since y is equal to log x with base a, implies by x is equal to a to the y, where x greater than 0, a greater than 0, a not equal to 1. The function is exist, y is exist if 2 minus 2 to the x greater than 0. The logarithm function is exist if x greater than 0. X is replaced by 2 minus 2 to the x. Y is exist if 2 minus 2 to the x greater than 0, which implies 2 greater than 2 to the x, which implies 2 to the x less than 2, which implies x less than 1. X less than 1. That means which implies x greater than minus infinity less than 1. So the domain of the function is x greater than minus infinity less than 1. The correct option, x greater than minus infinity less than 1. Domain means collection of x values. Clear? Okay, note down. Next, question number 4. If f such that close bracket 1 infinity open bracket 2 close bracket 2 infinity open bracket is given by fx is equal to x plus 1 by x, then f inverse equals to dash. Solution. F so that close bracket 1 infinity open bracket 2 close bracket 2 infinity open bracket. F so that this is given by fx is equal to x plus 1 by x. When x is equal to 1, y is equal to 2. When x is infinity, y is infinity. X is equal to 1, y is equal to 2. So this point is 1, 2. When x tends to infinity, y tends to infinity. The graph shows f is by gt. Fx is equal to x plus 1 by x is bijective. Since it is a increasing function, every increasing function is 1, 1. The function is bijective in this interval. F such that close bracket 1 infinity open bracket 2 close bracket 2 infinity open bracket is bijective. Every bijective function is invertible. That means the inverse is exist. It is y. Fx is taken as y. We have to find out the inverse of the function, which implies f inverse x is exist. Since the function is bijective, the graph shows the function is monotonically increasing. X equal to 1, y is equal to 2. The minimum value of the function is 2 in this interval. F inverse x is exist. Now y is equal to x plus 1 by x, which implies y is equal to s square plus 1 divided by x, which implies s square plus 1 is equal to xy, which implies s square minus xy plus 1 is equal to 0. Is a quadratic function. Is a quadratic on x, which implies x is equal to minus b, that is y, plus or minus b square, that means minus y square, that is y square, minus 4 sc, that is equal to 4, 1 into 1, divided by 2 into a means 1. A is equal to 1, B is equal to minus y, C is equal to 1. So x is equal to y plus or minus root of y square minus y, which implies y is equal to fx, x is equal to f inverse y. F inverse y is equal to y plus root of y square minus 4 divided by 2. X is positive and also y is positive. X is positive in this interval and y is also positive. X greater than 0, y greater than 0. So we will take the positive sign. F inverse y is equal to y plus root of y square minus 4 divided by 2. Since y is positive, y belongs to close bracket 2 to infinity. Also x is positive. That means f inverse y is also positive. Putting x for y implies f inverse x is equal to x plus root of s square minus 4 divided by 2a, that means 2, is the inverse of the function. So the correct option is A, that is f inverse x is equal to x plus root of s square minus 4 divided by 2. Clear? F so that close bracket 1 to 1 infinity open bracket 2 close bracket 2 open bracket infinity is given by fx equal to x plus 1 by x. At x equal to 1, the value is 2. The minimum value is 2. The maximum value is infinity. The function shows it is monotonically increasing. When x varies close bracket 1 to infinity, y varies 2 to infinity, close bracket 2 to infinity open bracket. So the function is bijective. Y is equal to fx, which is equal to x plus 1 by x is bijective. That means f inverse is exists. Y is equal to x plus 1 by x, y is equal to s square plus 1 divided by x, which is same as s square plus 1 is equal to xy, s square minus xy plus 1 equal to 0, x equal to y plus or minus root of y square minus 4 divided by 2. Y is equal to fx, x equal to f inverse y. Both x and y are positive, x belongs to this, y belongs to this. X belongs to this set, y belongs to this set, x greater than 0, y greater than 0, y belongs to close bracket 2 to close bracket to infinity open bracket. So we will take the positive sign, y is equal to plus of root of y square minus of 4 divided by 2. Since both x and y are positive. So f inverse y is equal to this, putting x for y, f inverse x is equal to x plus root of s square minus 4 by 2 is the inverse of the function. So the correct option is A. Note down. Question number 5th. Let fx is equal to sin theta into sin theta plus sin 3 theta. Then f theta is dash greater than equal to 0 when theta greater than equal to 0, less than equal to 0 for all theta, greater than equal to 0 for all theta belongs to set of real numbers. D less than equal to 0 when theta less than or equal to 0. Solution. Given f theta is equal to sin theta into sin theta plus sin e theta, which is equal to sin theta into 2 sin c plus d by 2, that is equal to 2 theta, c minus d by 2, that is equal to minus theta. Since sin c plus sin d is equal to 2 sin c plus d by 2 into cos c minus d by 2, which implies 2 sin theta into sin 2 theta cos minus theta is equal to cos theta, which is equal to 2 sin theta into cos theta into sin 2 theta. Cos minus theta is equal to minus theta is equal to cos theta. Cos minus theta is equal to cos theta. 2 sin theta into cos theta, that is equal to sin 2 theta into sin 2 theta, which is equal to sin 2 theta whole square, which is equal to sin square 2 theta greater than or equal to 0 for all theta belongs to set of real numbers. If theta is equal to 0, then sin square 2 theta is equal to 0, otherwise greater than 0 for every real theta. That means theta belongs to set of real numbers. A greater than equal to 0 when theta greater than 0, false. B less than equal to 0, false. Greater than 0 implies f theta greater than equal to 0 for all theta belongs to set of real numbers. Less than equal to 0 false, greater than equal to 0 for all theta belongs to set of real numbers. It is the correct option. Fourth, less than or equal to 0 only when it is false. So the correct option is C. Clear? Clear? Okay. Note down.